Hi guys, how's it going? This is Tupa. In this video, I'm going to show you how you can solve this quadratic equation here. It says x squared minus x minus 20 equal to 0. Okay, I'm going to show you how you can determine the factors and also how you can factorize and then subsequently get your actual answers. Okay, so I'm just going to wipe up everything. I have a slide that has the first few problems. We're going to use that. So what you have here is you have x squared minus x minus 20 equal to 0. There's a chance that this is factorizable, but then you wouldn't actually know it just by inspection unless you know this particular problem. If you're interested in knowing how you can know whether this is factorizable or not, the b squared, which is called the determinant of b squared minus 4ac, it must be a square. So it must be a square, e.g. 100. If it's 100, then you know that this is factorizable. I'm saying factorizable in the sense of, can you put two brackets here and then actually find the factors and then solve this way? Okay, some of the questions you cannot do that. So here I'm just going to test it out with you. Okay, so remember these symbols b squared minus 4ac, they're actually coming from the general formula form. The general equation, the general quadratic equation, which says ax squared, then plus bx, then plus c, okay, so equal to 0, the general quadratic equation. Remember, in this case, a equal to, just by comparing the coefficients, a would be equal to 1, b would be equal to -1 here, and then c would be equal to -20, okay. This is not very important in this case, just because we actually have a case where it's factorizable. But then if you just want to, if you're confused, you don't know whether you should apply the quadratic formula or just straight on factorize, then this is a good exercise for you. So b squared, yeah, when I'm substituting, I always use my brackets, okay. It helps me keep my signs sane. It helps me keep my signs in a way that I cannot get them screwed up. So here it's -1 to the power 2, so it's obviously 1, and then here it's negative and negative on the 4 and then on the 20. So here I'm going to get positive what? Positive 80. Okay, when you add this, you actually get 81. 81 is a perfect square. Okay, so 81, it's a perfect square. So this is good. It means that this is factorizable. So if it's factorizable, how do you find the factors? So here you're supposed to determine what's called the product. The product for this case, for the case where the coefficient is 1 here, the product would be equal to AC, okay? So AC, for the case where this one is 1, it's simply C here, okay? So the product would be equal to -20. In other words, you take the coefficient for x squared and then you multiply by the last number here, which is a standalone number. You get your product. And then your sum would be the coefficient of x. So in this case, it's just -1. So the reason this is important is that these are the guidelines that can help you find the factors for which you can factorize the expression. Okay. So here, the way that I like to teach my students is you take the product, just ignore the signs for now. Okay. So I'm just going to take the product to be 20. So I can start with 20 multiplied by 1. I want to change it up, okay, until I have something that I can work with to get -1, okay, two numbers that I can work with to get -1. So I can actually go ahead and divide this 20 by 2, so I get 10. And then if I divide this one by 2, I can multiply this one by 2 as well. I get 2. And no, notice that I didn't actually change the product. The product is still the same. This is 20, this is 20. So I can keep on doing this exercise until I have a sum of -1. I have numbers that can give me that sum. So here I can divide this one by maybe 2 this time. Then if I divide this one by 2, I get 5. So I can multiply this one by 2. Okay, so you divide by one number, you're supposed to multiply the other number by the same number. So I get 4 here. Okay, so you don't write equal to 20. It's unnecessary. I was just writing to illustrate to you that we're not changing any math here. We're just changing the presentation. or the number combinations. Okay, so you know you have 5 and 4. These ones you can work with. So if you know your direct numbers very well, to get -1, it means that you'd have -5 plus 4. Okay, so it's like a tug of war. -5 is saying let's go to the left, and then 4 is saying let's go 4 steps to the right. So at the end of the day, the compromise would be -1. Okay, so this one would be the more dominant one, so it'd be negative. And you say bigger size number minus smaller size number, then you just get 1. So your numbers are actually this number here and then this number here. Okay, so this one will be positive, obviously. So here you can actually straight on write -5, then here +4, like this, equal to 0. And then once you're done with this, either of this bracket could be 0. Okay, so x minus 5 equal to 0, or x plus 4 equal to 0, like this. So x would be equal to 5, or x would be equal to -4, like this. Okay, so this is just about it. This is how you work it out. Okay, so again, you don't actually need to justify your factors using this thing here called the determinant. Okay, so you don't need to justify this using the determinant. I was just showing you when you're confused, when you don't know whether you're just supposed to use direct factorization or not, then you can actually apply this. Okay, you can also work out the same problem using quadratic formula, interestingly. So I think we should go ahead and do that. Okay, so x is equal to quadratic formula. Recall it from memory, you expect it to, but then I think they actually give you the equation as well. Okay, so it's b squared minus 4ac here, all over 2a. Okay, so the reason why we're saying that this one should be a perfect square is that if it's a perfect square, then the square root can dissolve without causing any decimals. Okay, so any unnecessary decimals that go on and on, we call them seds. Okay, so we avoid seds by having this part here, which is called the determinant, as a square. So anyway, you can do the substitution because we already identified that a is equal to 1 here, and then b is equal to -1, and then c is equal to -20. So you can actually go ahead and say negative, then b is equal to -1, so -1 plus or minus square root of b squared. I always use brackets, okay, so that I don't get my signs screwed up. Okay, c is equal to -20, like this, and then over 2, your a is equal to 1, like this. Okay, so you can actually just going to squeeze my math into the space here. So here I get this one will be positive, so it'd be x equal to 1, then plus or minus. Then here you'd be having 1. Okay, so here you'd be having 1, then plus this one would be 80. So it'd be getting 81, so square root of 81, like this, over what? Over 2. Okay, so my x would be equal to 1 plus square root of 81 would be 9, so over 2, or 1 minus square root of 9 of 81, which is 9 over 2. Okay, so I can actually get, at the end of the day, this one would be 10 over 2, which gives me 5, and this one would be -8 over 2, which gives me -4. Okay, so you can actually work out the same problem and get the same answers, okay, using quadratic formula. This has been fun for me. I hope it was fun for you as well. This is just about it. This is how you work it out.